Welcome to a lesson with Dr. Powell. Let's take a look at projections and how to compute them, and where it comes from, kind of an introduction. Well, let's take a vector, say right here, call this V, so this one right here, and let's try to project it onto this ramp or this line right here. Um, Now, how do we do that? Well, let's consider an idea. See V. What happens if we split it up into something like it's the sum of two things, like the sum of this plus the sum of that? We look at the projection of this onto that ramp and the projection of this onto the ramp. Look, notice the sum of the projections is the projection of V. And it so happens that that the idea of taking a projection length um, preserves addition. So if I add before, it's like I'm adding after. And we can use that idea, especially if we split up a vector V. Let's suppose we have a vector V and it's split up into a vertical component and a horizontal component. And if I add those together, I'd get my vector. Now let's just consider how this projects onto a ramp, say. All right. Now, maybe to simplify things a little bit, let's consider the ramp itself as being defined by a vector of length 1, so a unit vector. And let's also just take a unit vector in the y direction, just to here. Now, if we take the projection of just this y vector on here, notice that it's the exact same as the projection of this guy onto the y. So they're kind of symmetric, which means that the y component of the unit vector over here is actually how this projects onto that. That's the projection length. It'll be the exact same. So if I have a length of 3 in the y direction and I want to project it down, it's simply 3 times the y component of that unit vector. So let's suppose the y component of this unit vector is u2. Okay, and maybe this is a vector, this is the unit vector right here, and suppose this is our v. All right, so that means that 3 times u2 is actually the projection. So rescaled, I just rescale the projection here by multiplying by 3. If I rescale this vector, I'm rescaling projection the same amount. So the projection just of the y component onto this ramp defined by this unit vector is 3 times u2. And by symmetry, thinking of the same argument with x, the projection of the x part, which would be 4 time, is just going to be 4 times u1, where u1 is the x component. And so we get 4u1, and then we add. So simply we just multiply down, and then we add. This is actually called the dot product between two vectors. Multiply into the respective components, and then you add. And the result is projection as long as u1 and u2 is a unit vector. And so hence we get a dot. We get this idea. And we define this idea more generally, dot product, where you have something like AB dot product CD. You just simply multiply the respective components, AC, and then you add between. So that would be called the dot product. This dot product is only projection when one of them is a unit vector and its projection onto the one that is a unit vector. Now, perhaps if the dot product is 0, then the projection after you rescale it will be 0 as well, which means we were perpendicular to begin with. So dot product being 0 is actually useful because it's a way of describing if two things are perpendicular or orthogonal to each other. Thanks for watching.